In this video, we're going to be finding the domain, vertical asymptote, and horizontal asymptote of the following rational function of f of x equals 3x to the third plus 7x squared plus 2 divided by negative 2x to the third plus 16. So in order to find our domain, we're going to go ahead and we're going to take our denominator and set it equal to 0. So we're going to have negative 2x to the third plus 16. We're going to go ahead and set that equal to 0, and now we're going to solve. You'll notice that this is very similar to finding our vertical asymptote. So we're going to subtract 16 from both sides, then divide both sides by a negative 2, and then we're going to take the cube root, and the cube root of 8 is going to leave us with just one, not two, numbers, x equals 2. So as far as the domain goes, what this tells us is that x can equal all real numbers, except x cannot equal 2. But what that does mean is that as far as our vertical asymptote is concerned, we've done the work. And our asymptote is at this value right here. It's at 2. And so by doing our domain, we've actually found our vertical asymptote as well, that x equals 2. To find our horizontal asymptote, we're going to take a look at our powers, at our degrees. So in our numerator, we have a degree of 3, and in our denominator, we have a degree of 3. And because they are equal, we're going to take those leading coefficients and stack them. So we're going to take 3 over negative 2, right? So let's write that down so we can see it. So we're going to take the 3x to the third plus 7x squared plus 2 over the negative 2x to the third plus 16. So again, because these are both 3's, what we care about is that right there. And when we reduce that, and we get 3 over negative 2, it reduces to just negative 3 over 2. So our horizontal asymptote is going to be y equals negative 3 over 2. And so we have found our domain, our vertical asymptote, and our horizontal asymptote. So finding the domain and the vertical asymptote are pretty similar. You basically do the same thing, it's just on how you write the answer. Now there are many examples of asymptotic behavior in real life. So we're going to go through an example that's going to show you how a vertical asymptote can be used to analyze the cost of removing pollutants from smokestack emissions. So here we have a utility company that burns coal to generate electricity. The cost in dollars of removing P% of the smokestack pollutants is given by C equals 80,000 times P divided by 100 minus P. And our P has to be between 0 and 100. And it can equal 0, but it can't equal 100. Now if we were to graph this, so we have it plugged in, and if we graph this, we change our window. So let's say we change our window. We went from 0 to 120. I know we can't get to 120 percent, but let's put that on there and we'll count by 20s. And then we'll have a 0 for our y, and we'll go up to 1,200,000. We'll count by 100,000. So now if we graph this, we're going to notice that we have an asymptote right here at 100%. So we can't actually ever get to 100%, but we can get really close. The question is how close. So let's get back to this. So we've used our graphing utility, and you're a member of a state legislature that is considering a law that would require utility companies to remove 90% of the pollutants from their smokestack emissions. And the current law requires 85% removal. So how much additional cost will the utility company incur as a result of this new law? So what we want to do first is find the cost for 85% and find the cost for 90%. So to do that, we can either plug in the 85% and the 90 in for P and use our calculator, or to actually physically calculate it, or we can use our table. So let's set it up first. So we can simply plug that into our calculator, or we can look at our table. So let's go ahead, let's just pull up our table and see if we can look at that a little bit better. So I'm going to go to table, so second table, and I could go all the way up to 85 or 90, And so let's see here. We want something that's going to be a little bit faster. So we can calculate. So go to second, calculate or trace. We want the value. So you want to know what is the value. Oh, let's go ahead. Let's go to the graph. Okay, so we'll graph it. So second, calculate. We want to know what is the value when x equals 85 or when our p equals 85. So we plug that in and we hit enter and it tells us that we get about $453,333.33. And so we'll round that to 453,333. And now we want to calculate, so second trace, so calculate the value when our p-value, our x is 90. And so here we see 720,000. So let's write that number down. 720,000. So it looks like a pretty big cost jump. And so we're going to calculate that difference. So we're going to take 720,000 and we're going to subtract 453,333 to get a value of $266,667. So the new law would require the utility company to spend an additional $266,667. And so this was an example of a vertical asymptote in a real life situation.